Greetings, Sir Isaac Newton.
Thank you so much for having me on the show.
Absolutely.
It's an absolute pleasure to be here.
Oh yeah, we're excited to have you too. How was the flight?
It wasn't too bad. My first flight in ever. But,
yeah.
Especially coming over from England,
Yeah,
Bits to get used to, but it was nice.
No, it's good, yeah. So, if you don't mind just telling the viewers who you are.
Of course. I am Sir Isaac Newton. I'm from England, Bit of a fun story. But I think I'm best known for my 3 laws of motion. First law is the law of inertia. An object in motion will stay in motion unless it's acted upon by another force, or an object at rest will stay at rest unless it's acted upon by an outside force.
Absolutely.
And I think that law has been pretty successful, as I've seen. My second law, force equals mass times acceleration, just defining force.
Yeah.
Greater mass when an object has more force behind it, greater acceleration,
Right, yeah.
It's,
unusual. And I've used that a couple times myself.
Have you?
Student. Yeah.
Oh, that's fantastic to hear. I love to see my work being appreciated, especially in classrooms.
Absolutely.
I never thought it would reach this far, especially, across the Atlantic.
Yeah.
But it's great to see. And then my third law, every action will have an equal and opposite reaction. This goes for collisions, this goes for, friction, it goes for a lot of things. It applies when any force is ever put into motion. Yeah, and it's great to see. So, do you mind breaking down what the show is?
Yeah, absolutely. So this is Hot Wings. Basically what we'll do here is we will, every now and then we'll try a wing with a different level of spiciness. So to start off, we'll have the mild spicy sauce, and then we go on to medium. Doesn't have a label, but that's all right. Then we have hot. Then we have Zassoff, and then we have Bernie Zassoff. So we'll make our way through and eat some wings.
And where are these wings from?
They're from Heavenly Buffalo. Yeah, so shout out to them. We're not sponsoring, but
we are definitely not sponsoring. These are very expensive wings.
Yeah, a little bit disappointed, but it's all right. We got what we wanted. So anyway, so I think we'll dig into our first wing here.
All right, let's go.
Let's do it.
All right.
Cheers.
Cheers.
No, not too bad. Wow.
How about roll?
No, it's good. Now, I know as soon as you got unfrozen and whatnot, you just hopped on the jet, headed over here.
Yeah.
So, I know you probably don't know a lot about Albert Einstein.
I think I've heard the name.
Heard it? You hear it on the way here?
I did. Real chatterbox next to me on the plane. Was not listening to him, but I think I heard the name a couple of times.
Okay, well that's good. Well, anyways, in 1905, he published a theory on special relativity, and then again in 1915 on general relativity, which we're going to go into in a minute. And then also, he's also known for his 2 postulates, which we will again get into, with some demonstrations too as well. You've got our figurine and Lego here.
Oh, wow.
I know you don't know a lot about Legos or cars or planes for that matter, but
no, I always want to be on horse and buggy.
Yeah, absolutely. So we're gonna get into our second hot wing before we get into that. So let's do it.
All right. Okay, no, there's spice there. There's spice there.
No, this is definitely. Yeah. Still edible though.
It is definitely still edible and it is still tasty.
Yeah.
This is something that I could see myself eating for fun, for like the joy of food. But
so we're gonna move on to Einstein's postulates now. So just to set the scene, well, let's pretend that there's a guy in this Lego figure, in this Lego car here, and this person here is waiting at the sidewalk. So let's pretend that this car can magically move at half the speed of light. Maybe he's a very good driver. So that's just the setup. He or she, there you go. He knows. So, for the first postulate, let's say that the driver, he himself, from his point of view, let's say he's not looking out the window, he feels that he is still. He's not moving at all. But from this person's point of view, the driver is moving at half the speed of light. So from his point of view, he's moving extremely fast. Now, Einstein's first postulate states that it doesn't matter. It doesn't matter who's moving, because for physics, all laws apply in this situation. So when neither God, that wind really got to me. I gotta tell you, I'm gonna take a quick sip of milk here. Alright. So neither of the frame of references matter, because they will always, laws of physics will always apply. So if neither of them have acceleration, laws of physics will apply. So now we're going to move on to his second postulate. So let's say that the driver turns on his headlights. So the headlights will be moving at the speed of light, obviously, but the car will be moving at half the speed of light. So how fast do you think that the headlights would be moving?
Well, if the light is coming from the car at the speed of light, and the car is moving at half the speed of light, then that light should be moving at 1.5 the natural speed of light. Is that absurd to assume?
It is.
It is?
It is, yeah. So according to Einstein's second postulate, the speed of light will always be the same in a vacuum, no matter what. So it doesn't matter if this car is moving at the speed of light and he shines his headlights. It won't be moving at twice the speed of light. It will always be moving at the speed of light. So that's his second postulate. Those are the first two.
That is a very interesting postulate.
Yes, it is.
Now, could it be theorized from that if the distances those objects will be moving in the same time frame are different, and the velocity of light has to be a constant, then perhaps the time that they experience will be different.
He's catching on now. But before we get into that, very interesting time dilation, by the way, we're gonna go ahead and eat another hot wing. Oh yeah. All right. Cheers.
Cheers.
Yeah, I got my throat a little bit there.
Oh,
So your trick is not to let it hit your lips.
I did not know that. You know, still survivable.
Yeah.
I am definitely still standing.
I'm working up a little bit of a sweat now.
I definitely, breathing is,
Yeah, it's getting.
the nose is running.
Absolutely.
I'd have loved to give these to the kids in my village. Watch them dance around.
Oh yeah. Oh, they would be happy for sure.
They would love it.
Now it's really good.
Yeah.
Alright. So I'm just gonna breathe through my nose for a little bit.
Yeah, I might try that.
Yeah.
Alright. But you know, not deathly.
No.
Not deathly. Okay.
Alright.
Yeah. So,
Alright.
time dilation.
Time dilation.
What's up with
Let's do
that?
it.
You know.
Well, we got a little board here to explain.
Oh, lucky me.
Well, you know what? You seem to be pretty well versed on this. You maybe want to take a shot at it?
Let me
Take a guess.
just take a whack, you know?
Absolutely, yeah.
So, as I understand, this gamma would be the coefficient of time dilation.
That's correct, yeah.
Okay, so this is the velocity of the Lego car. This is the speed of light. That means the greater the velocity of the Lego car, that would turn the denominator into a smaller number. Therefore, the coefficient of time dilation would be greater.
That's right.
So therefore, objects moving at a greater velocity experience time slower. That is very interesting.
So that means that this car, the person in this car would actually experience time slower than that of the person at the sidewalk. The person moving at half the speed of light would experience time slower. Can you believe that?
That is extraordinarily
It's amazing. How does that, it's mind-blowing. So, to better explain time dilation, let's pretend that the person in this car turns on self-driving mode and gets in the passenger seat. And let's say that he puts a mirror across from himself and shines a flashlight at the mirror. Now, he would see that the light goes through the mirror and back at him, right? As any normal person would. Maybe you go upstairs in the bathroom and you shine a little flashlight in the mirror, you see how it works? Here it goes right back to you. But the person here on the sidewalk, what they would see is the light going to and fro the mirror, but it's also moving in the car's direction, right? Interesting, right? So what that means is that the distance that it's traveling is it's increasing while the velocity stays constant. So what does that mean for the time, right?
That means the time will be moving at a different rate,
Right.
depending on the perspective.
Absolutely. And that's to help better explain what we got right here, this formula. You know, it took me, how many tries to understand it. So I had to, for the viewers who aren't up to speed, which I completely understand, we got the demonstration here, but that explains this equation right here.
So feel free to rewind.
Absolutely. I had to do it a couple times, so don't feel bad about it. Yeah, so now, I think that we're onto our fourth wing. Cheers.
Okay, cheers. We ready to do this. Oh, they're slow burners too. Oh, they're slow burners.
It hurts.
Back to the
Oh, it hurts. Ugh. Just gonna wipe my tears.
burns when it's open, it burns when it's closed.
Yeah, I'm starting to feel a little bit lightheaded here. So while my tongue regains consciousness, I'm gonna just mention that was our little presentation on special relativity, and next we're gonna do general relativity, which I think he's getting the hang of this now. I mean, I think he might be able to. Explain this one for us.
I'll try.
You want to go for it?
I might have a demonstration lined up. Mind if I just Alright, so even though I just got unfrozen, I'll take a second to talk about general relativity, which is when we add gravity to special relativity. So, if we imagine the space-time continuum as a plane, let's imagine 2 points on this plane. We have a quarter and a penny. Now, if light's going to be traveling between these 2 points, it would travel in a straight line because that's the closest, fastest way to get between 2 plates. Now, if we place a heavy object on this plane, I'll just use this to visualize, then, yes, light will still be traveling in a straight line, but it'll appear to curve because of the effect the heavy object has on the light traveling. Now, this is also a good way to visualize gravity, which is something I know a thing or two about.
Oh yeah.
So I know a thing or two about gravity. So if we imagine, instead of gravity, it's just a force attracting 2 objects, if we imagine it as a dent in the space-time continuum, then other objects will travel into that dent. So, using a ping pong ball as an example, it will travel towards the heavier object. And when it has inertia or force behind it, it will rotate around. I can do a little bit of and that is called orbiting, because it is constantly falling into the orbit, but has enough force to keep going around.
I'm glad I placed my faith in you to do this. This is a great representation.
Well, that's just what the theory says.
Anyways, so I think we're ready for our last wing. This is gonna be interesting. I'm still, finishing up my almond milk for this one, so All right. Well, moment of truth.
This is what it comes down to.
Yep.
Yeah.
We got our last hot sauce.
This is Bernie Zashoff.
Oh yeah. All right. Lord.
Is there anything we should say before this?
Maybe our prayers. I gotta say, because that last one I was recovering for a while, so Yeah. See, that clears my sinuses right there.
There's a.
I'm not supposed to be able to smell right now. That gets in there.
Why shouldn't you be able to smell right now? Is there any reason you can't smell right now? That you need to...
Yeah, no. We're good. We're good.
We're good.
We're good. Oh, there we go. That's show that to the camera. Look at that. That is
And feel free to go to Heavenly Buffaloes and get this yourself.
Yeah.
I actually encourage you guys to do that.
Yeah, no, absolutely. And, okay. All right, cheers.
The fact that it hasn't hit me yet, terrifying. And there it is.
Okay, I'm not. Oh, there we go. It's coming. It's when you put your mouth together.
Oh God.
It's when you put your mouth together and it. It really starts to. Oh, this doesn't help.
That's it.
Yeah, that's.
So, is there anything left to say about general talking? Don't talk. Here's what I learned today.
My tongue is paralyzed right now.
Here's what I learned today. I learned time dilation. I learned Einstein's postulate. I learned the theory of general relativity and space-time continuum. Overall, very educational. And I learned...
We hope you learned too, by the way.
I learned that if someone warned you, this is really spicy, have some trust in other people.
And that's basically it for today. But I just wanted to announce that there will be a dance going on this evening.
There's a dance this evening?
Yeah, and I just wanted to say you're welcome to come. And I hope you have a great time there. And maybe if you recover, I'll see you there.
Maybe it'll be a post-credit scene. For now, thank you guys so much for watching.
Thank you. And thank you for coming on the show.
We hope you learned something. Thank you so much for having me.
Absolutely. Cheers.
Cheers.
See you next time.
See ya.
Alright, ready?
Here, come on.
Bottoms up. Damn!
So what I love about general relativity is it's really the most wonderful thing on earth.
Absolutely, yeah.
The time dilation is what really
it's
matters.
amazing.
Because
How did Einstein come up with that?
this man just sat in his room and thought, you know what? Time isn't real.
It's not real. It's
whenever I want.
literally exactly. It's all in
And
your
it
head.
was the
It's all
most
in your head.
genius thing ever invented.
Absolutely.